So today we're going to talk about scientific notation, which is going to be kind of an extension on what we talked about yesterday. And so we're going to look at now scientific notation was developed in order to deal with multiplying and adding and subtracting super large and super small numbers. Okay. So scientific notation always takes this form. It begins with a number greater than 0 and less than 1. Okay. So this has to be the number 1 through, I'm sorry, greater than 0 and less than 10. So the number 1 through 9 has to be the first number. Then there has to be a decimal point. Then the rest of your numbers, followed by, all right, we got a couple more people joining tonight. Let me get them. This is Vivian. Charlie. Right. Okay. So the first number has to be a number between 1 to 9. Then you have a decimal point. Then you have the rest of your numbers. Then we have this times 10 to a number. Okay. So in order for this to be scientific notation, we have to multiply it by a base 10, and there has to be an exponent. Okay. And there can only be one number to the left of the decimal, and that number has to be 1 to 9. It can't be a 0. So this number right here is in scientific notation, and this number right here is in scientific notation. Hold on, I think we got a question come through. Got somebody else. There we go. Okay. All right, there was a question about week 7. So what I did was I did not extend week 7 into this week. Week 7 is just one day last week. So the content that I was going to do in week 7 got pushed later, so week 8 and so on and so forth. So last week there's only one class, and but there's still 5 homework assignments that you have the option of doing and a quiz. So just to kind of clear that up. Okay, so we are in the middle of doing scientific notation. Now, if we actually were to write this number out, this is 3.80 times 10 to the 8th. What would that actually be? We would actually have to move this decimal point to the right 8 positions. 2, 3, comma, 1, 2, 3, comma. So this number is 380 million. But rather than writing 380 million, mathematicians and scientists came up with an easy way to record numbers when they're super large, also when they're super small. So in this case, we have times 10 to the negative 6th. So in this case, we would have 1, 2, 3, 4, 5, 6, 9098. So this number would be 0.000002998. So you can see how we have a super small number and a super large number. And multiplying those two together could be somewhat cumbersome. Or even if you were using a calculator, there's a high probability that you're going to miss the exact numbers of zeros. So this was developed as a way to kind of deal with those super large and super small numbers. And that is putting numbers into scientific notation. So let's put this number, 384, into scientific notation. How do we do that? Okay, so this number is 3 digits. So what I'm going to do is my first number, 3, then I have a decimal point, then I have the rest of my digits, 3.84. Now, 3.84 is not the same thing as 384. So what I say then is I multiply this by 10, but if I just multiply it by 10, 3.84 just becomes 38.4 if I multiply it by 10. I have to multiply this by 100 in order to move this decimal point over 2, right? 3.84 times 100 is 384. So I'm going to multiply it by 10 to the second power. 10 times 10. 10 times 10 is 100. 100 times 3.84 is 384. But I'm writing 100 as a base 10 and an exponent of 2. So all my scientific notation numbers are going to have the same base 10. And then I'm going to have an exponent. So in this case, 8 zeros. In this case, -6. In other words, I'm going to go the opposite way. Rather than adding zeros to the right, I'm going to add zeros to the left if it's negative. All right, so the number 384 becomes 3.84 times 10 to the 2. Now, if I start with a number like this, let's say 2.73 times 10 to the second. How do I go back to the regular number not in scientific notation? All right, so we have this number here, 2.73. This exponent here tells me how many decimal places I'm going to move. So from right here, I'm going to move 2 to the right to give me 273. If I have 420 or 4.201 times 10 to the -2, what would that be? Well, I would take this decimal point here, and rather than going to the right 2 places, I'm going to go to the left 2 places. So this would become 0.04201. The decimal point used to be here, and then it moved 2 to the left because of the -2. So where does this come from? So let's look at this a little more straightforwardly. So 10 squared, 2.73, times 10 squared is 10 times 10, or 100. 2.73 times 100 is 273. Now remember here, when I have a negative exponent, 4.201, that's the same thing as that exponent in the denominator, but positive. Remember, we looked at that yesterday. If I have a number, a to the -n, that's the same thing as 1 over a to the +n. So here, rather than multiplying it by 10 to the -2, I can divide it by 10 to the +2. Okay, 10 squared is 100. So this is literally taking 4.201 and dividing it by 100. And if you do that, if you stick that into your calculator or you just look at here, anytime I divide by 100, I'm moving the decimal place over 2 from here to there. So here I'm multiplying by 100, and if it's negative, I'm dividing by 100. All right. So let's look at another example. Okay. 6.8735. Let's put that into a regular number, not scientific notation. How do I do that? Okay, well, this positive times 10 to the positive 3 means I take that and I move it to the right 3 spaces. 1, 2, 3. So I get 6,873.5. Okay. 7.00012 times 10 to the negative 4. What is that? Okay. Well, I start here, and rather than going to the right, like I did here 3 spaces, this is a negative 4, so I'm going to go to the left 4 spaces. 1, 2, 3, 4. So I'm going to have 0.00007000012. So that number would be 0.000700012. All right, so now let's go the other way. Let's go from a number into scientific notation. So let's do 6,389,000,000. Okay. How do I put that into scientific notation? So remember, if we take our first number, and then we'll have our decimal point. So how do I get my decimal point there? Well, right now in the big number, my decimal point would be here. So it would, in order to get from here to here, it would have to move 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6.389 times 10 to the positive 9. And we could check that. 6.389 times 10 to the 9th. All right, so we would have 6,389. Our decimal point starts here, and we're going to move it to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excuse me. So 0, 0, 0, 0, 0, 0. 1, 2, 3, boom. 1, 2, 3, boom. 1, 2, 3, boom. So 6,389,000,000. All right. So that's converting numbers to scientific notation and from scientific notation. Now what we're going to do is we're going to multiply. And when you multiply, you're on scientific notation, just like on the percent problems on your quiz, you will be allowed to use the calculator. So I'll make sure to note that on the quiz, but you're allowed to use calculator on scientific notation. Okay. All right. So let's do 3.887 times 10 to the 5th times 4.324 times 10 to the negative 7. All right. Now, if we were actually to convert these into their regular numbers and look at what we're dealing with, you would see why scientific notation was kind of developed. So first of all, if we take this one, 3.887, we're going to move that decimal point to the right 5. So 1, 2, 3, 4, 5. So 388,700 times. Now here we're going to go to the left 7 rather than the right. So I'm going to make sure to put my 4 over here because we're going to be moving it to the left 7. 1, 2, 3, 4, 5, 6, 7. So times 0.00000004324. So you can see how these are huge and small numbers to type into your calculator and try to keep track of if you have a big, long math problem that you're trying to work out. So to make it easier, we do this, excuse me, in scientific notation. So what does that look like? Well, let's write this out again. All right. So here we have multiplication, 3.887 times 10 to the 5th times 4.324 times 10 to the negative 7th. So we're multiplying 1, 2, 3 times, right? This is like A times B times C times D. Multiplying 3 times. And remember, one of our properties is we can multiply in any order we want. We can do B times D times C times A. We can do A times C times D times B. Obviously, we can arrange these in any order we want. So what I'm going to do is I'm going to put these two numbers together first. 3.887 times 4.324. Then I'm going to put the two tens times 10 to the 5th times 10 to the negative 7th. Now, why would I do this? The reason I'm doing this is now we can see a little bit more clearly that we are multiplying two numbers here of the same base with exponents. And as we learned yesterday, if I am multiplying two numbers, with the same base, a to the n times a to the m, I can add the exponents, a to the n plus m. So what I will do is I will put this in my calculator. 3.887 times 4.324. And I get the number 16.80738. Okay. Then I'm going to multiply that by 10. And here I can combine the two exponents. This would be 5 plus -7. 5 plus -7. And 5 plus -7 is -2. So this would be 16.80738 times 10 to the -2. Okay. Now, is this number in scientific notation? It is not. Why? It has the times 10. It has an exponent. Yes, it does. But remember that the first criteria of a number in scientific notation is that there is a number 1 through 9 and then a decimal. Here, there are two numbers and then a decimal. So we're going to have to convert this into a scientific notation number. So right now, 7388 times 10 to the -2 is our number. So I'm going to move this decimal place 1 to the left. Okay. Now, this number, if I were to convert it into an actual number, says to move it 2 to the left. Okay. So if I'm moving this 2 to the left in order to convert this back to a regular number, then if I move it to the left 1 in order to put it in scientific notation, 1.6807388 times 10, what goes here? It can't be -2 anymore because we're not moving this 2 to the left, right? Here was our original number. And if I move it 2 to the left, that gives me 0.1680738. It moved 2 to the left. So if I move it 1 to the left, and now here is my decimal point, that means that I need to put a -1 here. Why? Because to put it back to its original number, I only have to move 1 to the left to get 0.1680738. Okay. So now we have 1.6807388 times 10 to the -1. All right, but we're still not done. The next concept that we need to talk about is what is known as significant figures or significant digits. Okay. Significant we'll just call them digits. All right. What are significant digits? You can only be as accurate as your least accurate number, right? Have you ever heard of the phrase, the chain is only as strong as its weakest link, right? So it's kind of that type of idea. When we look at our two original numbers here, we're going to count and see how many significant digits we have. Both have an original number. Okay, or what I should say is one number in front of the decimal. But then we're going to look at how many numbers do we have after the decimal in each one of these numbers. They both have 3. This is 887, and this is 324. So what that means in our final answer, we can only have 3 digits after the decimal. Okay, so that means this number right here, this 0, we have to round up to 1 because the number next to it is cut off, and that's a 7. So that means the zero's rounded up to 1. So this ends up being 1.681 times 10 to the negative 1. And that is our final answer. 1.681 times 10 to the negative 1. Right. Now let's look at dividing. Dividing is going to follow pretty much the same principles. All right, here we have 4.2 times 10 to the 5th over 6.8735 times 10 to the 8th. So the first thing that we're going to do is actually divide the two 4.2 divided by 6.8735. That's the first thing. So 4.2 divided by 6.8735. All right, that's going to give me 0.6110424092529. All right, there'd be a lot of other digits if my calculator was longer. Now, I can already tell you we're not going to have that many digits because of what we just talked about with significant digits, but let's keep those there for now. And then at the end, and only at the end, is when we modify and we round, okay? So here we have the same base, 10 and 10 with exponents. And if you remember from yesterday, if we have the same base and we're dividing and they each have an exponent, that becomes a to the n divided by a to the m becomes a to the n minus m. So that's what we'll do here. Times 10, that's a, and then to the 5 minus 8. Okay. So now we have 0.6110424092529 times 10 to the negative third. Okay. Now notice again, our leading number here is not a number between 1 and 9. That means that we have to take our decimal point and we need to move it to the right one. Okay. So this becomes 6.11042409252 times 10. Now, what do I do here? Well, originally, to get my number here, if I started here, 0.6, and I went to the left 3, 1, 2, 3. Okay, this is the number, 0.0006. So here, in order to get to the same number of zeros, 0.000. All right. So 0.000611, just like it is up here in the original. I actually have to move it 1, 2, 3, 4 to the left to do that. So this is 6.1104240922529 times 10 to the negative 4. All right, now it's in scientific notation. Now I'm going to look at significant digits. So let's look back here. In my bottom number, I'm accurate to 1, 2, 3, 4 past the decimal. In the top, I'm only accurate to 1 past the decimal. So I can only be as accurate as 1 past the decimal. So that would be right here, this number right here, 6.1. Since the number next to the 1 is also 1, I don't have to round up. So my final answer then becomes 6.1 times 10 to the negative 4th. All right. Okay. Now what I want to do is double check something real quick. Oh, we need to talk about adding and subtracting. Yep. Okay. So let's say that we have two numbers, 4.53 times 10 to the second, and we're going to add that to, let's say, 6.84 times 10 to the third. Okay. All right. So are these like terms? Okay. So if we remember what like terms are, remember terms are things we add. So if I had 5x squared plus 6x cubed, are those like terms? Can I add those together? Well, the answer is no, because even though we have the same variable, we do not have the same exponent. Now, if there was a way to make them the same exponent, then we could add them together. And that's what we need to do in scientific notation. So here I have 4.53 times 10 to the second power plus 6.84 times 10 to the third. So I can do one of two things. I can modify this so this becomes 10 to the third, or I can modify this so this becomes 10 to the second. I'm going to modify this and make this times 10 to the second. So how do I do that? Well, if this is times 10 to the third, that means I would have to move the decimal place over 3 digits. So this number is 6,840. Well, if I'm going to change this to a 2, then I have to move my decimal place to here so that I only move it over 2 to be 6,840. So that's what I'm going to do. This is going to be 4.53 times 10 to the second plus, now I'm going to move this number out of scientific notation, but it is going to have the property of having the same base, 10 to the second, 10 to the second. So what that allows me to do is combine like terms. So again, let's say I have to kind of remember back to 5x to the second power plus, let's say, 3x to the second power. How do I combine those? Well, this becomes 8x to the second power. Remember, we're not adding the seconds together. This doesn't become x to the fourth. We're adding the coefficients together. And the x squared factor remains the same because I could factor this x squared out. If I factored the x squared out, this becomes 5 plus 3. 5 plus 3 is 8 times x squared. That's where that's coming from. So we can combine these by adding the coefficients. Same thing here. We can combine these two by adding these numbers that we multiply by 10 to the second. And so I'll use a calculator, but you can, this is addition, so it's kind of simple to do. But you do 4.53 plus 68.4, and that gives us 72.93 times 10 to the second. Now, we will need to leave this, even though we converted this out of scientific notation in order to perform the operation. Here, for our final answer, we're going to need to convert this back into scientific notation. So, if we look at this, this has to be 2, would move 2 to the right, so 7,293. If we move this to the left here and made it 7.293, then this would have to move over 3. Whoops, times 10 to the third. So our final answer, I'll write it over here, is 7.293 times 10 to the third. All right, we'll keep that'll be your final answer. 7.293 times 10 to the third. All right, so now I'll work a subtraction problem. It's going to work the same way as the addition problem, but we'll do that example just to show. We'll have 7.63 times 10 to the negative 2 minus 8.64 times 10 to the 7th. Okay. All right. So first things first, we need to get these exponents to be the same. So we can either modify this so that this negative 2 becomes 7, or we can modify this so that the 7 becomes negative 2. I'm going to modify this and make the negative 2 7, just because I'd rather work with positive exponents. You'll get the same answer either way. So right now, this number, if we move over to, right, is 0.0763. So if I manipulate this, I need to move then from this spot over 7. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. Good. Okay. Now, since I've moved that whole way, and we're out of scientific notation here, 0.00 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, 763 times 10 to the 7th. All right. Remember, when we go to the 7th, we go to the right. So when I go to the 7th here, if I were to move this over, 1, 2, 3, 4, 5, 6, 7. Now we're back to here, 0.0763. That's my original number, 0.0763, which is also 7.63 times 10 to the negative 2. So this is the number if I have times 10 to the 7th. Then we're going to subtract 8.64 times 10 to the 7th. Okay. So now I have like terms. Now I can subtract. So we'll see if my calculator can go that tiny on this number. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros. 763. All right. And we're going to subtract 8.64. Okay. That's going to give us negative 8.6399. See, 1, 2, 3, 4, 5, 6 nines. 1, 2, 3, 4, 5, 6 nines, then 237. All right. And times 10 to the 7th. Now, what you'll notice is this is already in scientific notation. We have a number here between 1 and 9. Actually, it's a negative, and I should have said that earlier. So this number here can be between 1 and 9, can also be between -1 and -9. Just can't be 0 here or larger than 9. In other words, like 10, 11, 12, so on and so forth. All right, so we have a -8 here, point. And so then we have the rest of our numbers, and then we have times 10 to the 7th. And we're not concerned with significant digits in addition or subtraction. So this kind of shows you what we're doing. And this makes sense if we think about this, because if you have 8.64 times 10 to the 7th, okay, and you subtract 0.00000000763 times 10 to the 7th, you can kind of see how the 763 took this number down a little bit from 8.64. So that seems to track. All right. Good deal. So we are good to go. That is all I had for today's class. You know how to convert a number into scientific notation, then from scientific notation back into a regular number. You can add, subtract, multiply, and divide scientific notation. And that'll be what's reflected on the next homework assignment. So class is dismissed. Yes, Vivian.
I was wondering if you could add my email to the homework emailing list. Um,
Okay.
because sometimes I think the my parent who has it just doesn't send it to me on time. So
No worries.
could I send you
Um,
it in the chat, my email in the chat?
yep. Go ahead and
Okay,
do that.
thank you.
That'll work.
Thank you, sir.
You're welcome. Have a good one.
Thank you, sir.
You are welcome. All right, don't leave yet, Vivian. That way I can get your email. Oh, wait, no. She left, but I think I got it. Okay. Krista, are you there?
Hola.
Hey, let me just add this to the. Sheena, thank you. All right.